Good evening, and welcome back to Knowledge in Progress. We are going to spend tonight on part 3 of our investigation into the origin of music in humans. In parts 1 and 2, we identified a lot of different sources and started reading through some of them. I had to interlibrary alone a few sources as well. And we started looking at the various lines of evidence for the origin of music, right? We have evolutionary lines, right? When did we physically have the ability to sing, for example? And archaeological evidence. So when is the oldest artifact that we have that could suggest that humans were making music? And today we're going to try to take those various lines of evidence and bring them together to answer our question. So if I bring us over to our graph, this is where we left off last time. This is going to be our question, the earliest evidence of music. We have a concept note that we made for music, and we had a bunch of different sources that we brought in. There are a few that are already linked, and we have a few sources that have not been connected to our concept yet. So my goal for today is to try to go through all these different sources, go through the ones that we haven't been able to go through together, and start connecting them to these concept notes and build up these concepts, and finally have one cohesive answer to the question that we're asking. This cluster, by the way, is our first investigation, right? This is why our ecosystem's more stable when they contain more species. Clearly, they're not connected to each other yet, but we saw some indication that somewhere along the lines, maybe a concept of evolution would link both the evolutionary evidence for music and the evolution of species in certain types of ecosystems together. But for now, they're going to stay separate, and we'll see how over time those connections build. Now, let's jump into this. So we have our question note, right? This is the question asking, what is the earliest evidence for music? We mentioned potentially archaeological evidence. We have evolutionary evidence, and a few topics that we wanted to look at, right? We have music. We have musical instruments. We saw some evidence about musical instruments. We're probably going to want to make that concept note today. Singing, when we talk about the evolutionary evidence, we're looking for the ability to sing. And I had made some potential concept notes for humming and whistling. I actually think I'm going to get rid of the one for humming for now, because the ability to hum comes along with the ability to sing, right? It's still our vocal cords maintaining pitch control. It's still our ability to sustain a rhythm over time. So we'll actually get rid of this. We'll lump that in under singing for now. And whistling, we may not be able to do much with this. The more I've been thinking about whistling, the more I think we're not going to find paleontological evidence for this, right? This is a lot of soft tissues, so this is what the mobility of the lips and the tongue are. Those don't fossilize very well, right? So I don't think we're going to be able to do anything here, but we'll leave it for now and we'll come back to it. And then, of course, we haven't written our current understanding yet because we haven't finished going through all of our sources. So let's go to our music note here, right? We had a few definitions here. We had a statement that there's a significant cultural component to the definition of music. What one culture would consider musical might just be considered noise by another culture. And then we also have the fact that music may have evolved to serve a whole range of different societal functions, including group cohesion, cooperation, and identification. But it could also have been a side effect of some other traits, right? There's lots of traits working together to make music, and maybe those traits evolved for other reasons, and music just kind of came out of that. So let's see what we want to do. I think a good next step is to create this musical instruments note, because we do have a lot of evidence about musical instruments that we talked about last time. So let's create this note. Again, if you click on a dead link in Obsidian, it'll automatically create a new note, and we're going to use our concept template. So, musical instrument. We're going to need to get our quick references, and then we'll go through some of the sources that we looked at last time to see where we can go with this. So let's go to Wikipedia, and we will search for musical instrument. And we'll immediately just copy this URL into our note. A musical instrument is a device created or adapted to make musical sounds. In principle, any object that produces sound can be considered a musical instrument. It is through purpose that the object becomes a musical instrument. So, there may be some other useful sources here, but let's actually start with that, right? It's a device created or adapted to make musical sounds. A device created or adapted to create music. And actually what we'll do is we'll use the term musical sounds. The classification as a musical instrument comes from its purpose, not its design. So if you start banging on a trash can in a rhythm and use it to make music, that trash can is at that point a musical instrument. We also want to get our Wiktionary definition. Just for completeness. And we'll copy that URL. A device, object, contrivance, or machine used to produce musical notes or sounds. So that's basically the same definition. So we have a claim here. Early musical instruments may have been used for rituals, such as a horn to signal success on the hunt or a drum in a religious ceremony. Now, this is interesting, and this is a good learning opportunity. There is no source cited here. If there was a source cited, there would be a little superscript behind the sentence indicating which source it was using. So this claim here right now is uncited. We'll have to look at the history section to see if they cite some sources there. The oldest object identified by scholars as a musical instrument is the simple flute. This is the one that we spent so much time on last episode, which is about 50 to 60,000 years old. So this is the oldest direct evidence of a musical instrument. So let's actually put that in here. The oldest archaeological evidence for a musical instrument is a bone flute dated to 50,000 to 60,000 years ago. And we have a source for this. If I can find the source. It's probably, yeah, there we go. And that should actually be in sources. All right. So we're going to cite Turk 2020. Turk 2020 Neanderthal. That is the paper that we read last episode describing that particular artifact. So now, by the way, if we go back to our graph view, we'll see that we have two concepts here, right? We have musical instrument and music, and we've tied this Turk source to the musical instrument concept. The musical instrument concept also links to music. And I should also check that we have musical instruments linked here, and singing will get linked later on. All right. So let's go back to Wikipedia. Many historians believe that determining the specific date of musical instrument invention is impossible, as the majority of early instruments were constructed of animal skins, bone, wood, and other non-durable biodegradable materials. Again, no source cited here. That may mean that the source will be cited in the history section. So we've got some, this is actually a cool example. So we're talking about old instruments being potentially easily degraded, right? So these are drums that are used in Cameroon and Africa, and these are slit drums. So these are going to be logs that are hollowed out, and you hammer over a slit in that hollow log to create a drumming sound. You can imagine over 60,000 years, right? Unless this is in a very specific location, right? Maybe it's in a peat bog somewhere, or it got frozen in a glacier, or it's stored in a really, really dry cave. This is going to break down over time, right? This is wood, it's going to decompose. So it's very unlikely that we would find an actual archaeological artifact of a drum like this. So let's look here. Archaeology. So we have way more flutes that are much younger than the Divshe Babe. I don't know how to pronounce that. Let's actually see if I can. Divshe Babe. Okay. Anyway, that's besides the point. We've got an artifact here. This is talking about 37,000 years old and later. These are probably some of those instruments that we described before. So if we go back here, try to organize my sources. Not this one. Here we go. So this particular paper had a lot of other sources, right? So we have 43 to 39,000 years ago, bone and ivory, 50, potentially 60,000 years ago. So we should cite this source here as well and say that other flutes and trumpets were found as old as 43,000 years ago that were already well developed. Other flutes as old as 43,000 were made of bone and ivory. Since these were already well developed, it is likely that flutes were already established technology by that time. We'll make a footnote here. This one is going to Montague. We can also, if I open that up again, say that conch trumpet. So shell trumpets are at least 20,000 years old. Shell conch trumpets are at least 20,000 years old. Evidence for other styles of musical instruments are likely unavailable before the invention of pottery because they were made of biodegradable materials. Remember, we talked about evidence for drums and ocarinas that were made out of ceramics, but that's not going to be before the Mesolithic because we didn't have pottery. Any drums or ocarinas, for that matter, that were made before that time would have been made out of wood or other vegetable matter and would have broken down over time. So this also is going to use the same source. Also Montague. It might be, well, this answers the question that we have, right? And that's for archaeological evidence for music, that 50 to 60,000 years is definitely going to be the oldest archaeological evidence for musical instruments that we have to date. So let's actually go ahead and take that and put it into our current understanding section here. So we're going to say the oldest archaeological evidence for music is 50,000 to 60,000 years ago. Musical instruments were likely well established before this. Let's actually, because this is interesting, make a note here, associated with a Neanderthal site, right? So this isn't Homo sapiens, this is Homo neanderthalensis. And we will cite, let's see, how did I do this in the previous question? No, we're not citing the sources here. We are linking to our actual articles. So we'll say archaeological evidence, a musical instrument, bone flute. There we go. Now that's linking. Musical instruments were likely well established before this. Now we go back to our graph view. You see this is getting more and more tightly linked, but there's our evidence for music. Now, let's have another look at that Wikipedia article and see if there's anything else we should be thinking about. So we've got these bone flutes of various types. And then the next site that we have here is Sumerian city of Ur. They found a lot of instruments there. They found lyres, harps, flutes, sistrum, cymbals, pipes. But these were dated just 2,500 years ago. So old, but nowhere near the tens of thousands of years that we're looking at. We have some bone flutes that date back 9,000 years. These were Neolithic, so late Stone Age. So this is another example of one of those slit drums. These are Aztec. So these may well have been, again, some of the earliest musical instruments, but there is no way that we're going to find evidence of them unless we get really, really lucky. At least older than the 60,000 years that we've been looking at. Got a lot of uncited sources in this article. Someone needs to go through the Wikipedia article for musical instruments and add some citations to things. But I think we can be fairly confident in our explanation for the oldest archaeological evidence of music. So let's jump back here. I do have a question here, and this is, what is the association between the hunting bow and the musical bow? This may not be a question that has been answered, so there may not be an answer out there to find yet. But one thing that the paper we read last time talked about was that we assume that the musical bow co-evolved with the hunting bow, since the oldest stone arrowheads are Mesolithic in origin. We assume the musical bow was developed then as well. And this is also Montague. All right. So let's look at our question again. And maybe look at that evolutionary line, right? We were talking about singing. So let's make a note for singing. And this is going to be a concept as well. And we will look up singing. The art of creating music with the voice. That's nice and plain. The art of making music using the voice. And we should link music. And again, for completeness, we'll go to Wiktionary. Singing. And the act of using the voice to produce musical sounds, vocalizing. All right, now what we've learned so far about singing is that it requires the ability to do several things, right? We need to have the ability to control pitch, which means we need a voice box that is flexible enough to make different pitches, right? So we have to have vocal cords that can adjust their tension appropriately. We need to be able to vocalize, which means that the mouth and the voice box have to work together in a way to make consonants and vowels. And there has to be the neurological ability to maintain a rhythm. Which source was that we were looking at last time? Was that Cross? this is talking about synchronizing. I do want to talk about the Geisman paper. I found that through Interlibrary Loan, and we'll talk about that in a little bit. Same with the singing Neanderthal. We'll talk about that as well. So let's search for Morley. Okay. Evolution and the physiological and neurological capacities for music. Okay. So we have a statement about the evolution of the voice box. The position of the larynx correlates with some curvature at the base of the skull, okay? So we can say that about 3 million years ago, ancestors of modern humans and their close relatives probably had a vocal ability similar to modern apes, but by Homo ergaster, we had some limited ability to start making vowels. And that's listed here. So we can say that the ability to vocalize developed between 1.75 million years ago and 300,000 years ago. That's a very long range, but let's go to singing. The biological ability to make the sounds associated with singing evolved somewhere between 1.75 million years ago, and that was Homo ergaster, and 300,000 years ago, and that would be Homo heidelbergensis. And we have a source for this. This is going to be Morley. And we can mention that we can say that this is based on the position of the larynx. Based on the position of the larynx, the biological ability, etc. Okay. Before this, vocalization was similar to modern apes. And I should say modern non-human apes. There we go. We should specialize, mention here that Homo ergaster did not have the full vocal range of modern humans. And that's going to come off of the same source. All right, so that is our singing. So the biological ability to vocalize evolved somewhere in this range. the biological ability to produce the sounds necessary for singing evolved between 1.75 million years ago and 300,000 years ago. So, this answers the question. It's not a very satisfying answer, but somewhere between 1.75 million years ago and 50,000 years ago was the origin of music. Depending on what you're looking for, the oldest archaeological evidence is about 50 to 60,000 years old. The oldest evolutionary evidence for the ability to sing was between 1.75 million and 300,000 years ago. Of course, this does not mean that people were singing at this time, right? They had the ability to, but behavior doesn't fossilize, so we have no good way of building on this. Now, we did have a couple of additional sources, so let's look here and see what we haven't connected yet. I've got two sources. I've got the Singing Neanderthal book. This one, it sounded really interesting. What I was looking at when I was reading it, it doesn't really go as in-depth as I would like. It does have an extensive source list in the back, so I may want to look more closely at that. But one thing that the author does talk about is that in order to have a language, you need a whole range of other skills as well, right? You have to be able to produce certain types of sounds, you have to be able to connect ideas to sounds, and so forth. And this author is suggesting that music is one of those skills that is required for language. I may actually link language here, because we'll probably talk about that at some point, and we'll link music. And they say something along the lines of, had a Neanderthal attended a rock concert, they would have liked it and recognized that it was music. I mean, honestly, that is a big claim to be making, and it's the sort of thing that makes me kind of not want to use it as a defining source. It's a really interesting read. And he particularly thinks that they would like rap music. There's reasons for that to do with the use of rhythm and whatnot, and the way that the author thinks rhythm would have been used to communicate information. But I would say, interesting read. I have to look at it more deeply, but it's probably not going to add anything very useful to our particular investigation right now. Which is too bad, because this was, it's just a fun title, right? Singing Neanderthals, the Origin of Music, Language, Mind, and Body. But we've linked that to music now, which leaves us with this particular source. And this is Gibbon's Song and Human Music from an Evolutionary Perspective. I have not read this paper yet. I got it in through Interlibrary Loan, but I figure we'll go through it together. So let's bring this over so you can see it. All right. Because gibbons do make a lot of very musical sounding calls. Produce loud and long song bouts that are mostly exhibited by mated pairs. It sounds like the parts are sex-specific somewhat. They have timing. They have interactions to form duets, and so forth, and so on. Let's see. Singing behavior evolved several times independently in the order of primates. That's going to be something that's going to be interesting to look at. But I'm actually going to copy that and put it in our note. Let's see. Structural and behavioral similarities suggest that of all vocalizations produced by non-human primates, loud calls of old world monkeys and apes are the most likely candidates for models of a precursor to human singing and thus human music. All right. Gibbons are lesser apes, usually combined in the family Hylobatidae within the Hominoidea, which includes the other great apes, including the humans. They live in trees. We've got relationships between different monkeys. Monogamous social structure. Monogamy is unusual in mammals, that is true. About 3% of species of mammals are monogamous, as opposed to 90% of bird species, which is really like a very clear distinction that is a very interesting question that we might look at in the future. Let's see. As in most other monogamous species, gibbon groups usually consist of one adult pair and 1 to 3 dependent offspring. So they live in little family groups in territories that they defend. And the author in this case is interested in their morning vocalizations, which we also call songs. We have a definition here for a song. What is usually understood by the term song is a series of notes, generally of more than one type, uttered in succession and so related as to form a recognizable sequence or pattern in time. Let's actually check that source, Thorpe. So this is about bird song. So what I'll do, I like that quote. I want to keep that quote, but I also want to make sure I attribute it to the correct author. So what I'll do here is say Thorpe, and this was 1961. Should be obvious from there that this is a quote of a quote in another paper. In time. And we don't need that comma there. All right. Depending on species and context, the bouts have an average duration of 10 to 30 minutes. But the author recorded one that lasted 86 minutes. Oh, here's one singing. Let me see if I can zoom in on that. That little face. That's actually kind of terrifying. Species-specific calls, vocal characteristics are used to reconstruct their relationships. Most species duet sing. So we'll say something like, most gibbon species mated pairs sing duets. We have some sonograms here showing the different types of calls. So we have a pair of Simon gibbons that are duetting. So males produce one or several distinct types of phrases that become gradually more complex as the song proceeds. At intervals, females insert long female-specific phrases that are commonly referred to as grade calls. A grade call consists of particularly rhythmic series of long notes uttered with increasing tempo or frequency. Males stop vocalizing at the beginning of each grade call and provide a special reply phrase, coda, to the grade call before resuming their more common short phrases. So the parts of these duets are sex specific and respond to each other. So, in addition, females of most species contribute phrases other than grade calls to the duets, but because grade calls and grade call sequences are so loud and stereotyped, most studies simply ignore the more variable portion of the female repertoire. That sounds typical of research. I'm sure there's all sorts of interesting stuff in there, but they don't go into it. All right. In contrast to what might be expected in primates and what we know about song development in birds, species-specific characteristics in gibbons are not learned. A hybrid raised by its parents in a zoo where no other gibbons are present receives only the male song of one parental species and only the female song of the other parental species as potential templates from which song learning would be possible. A female hybrid between male H. lar and female H. muelleri never hears a grade call other than H. muelleri. If grade calls were learned, the hybrid should produce those of H. muelleri. If the parents are a male of H. muelleri and a female of H. lar, the hybrid will only hear grade calls from H. lar. But neither of these happen. They produce the same hybrid-specific grade calls that combine elements of both parental species. So we'll say something like species-specific call patterns are not learned. Hybrids produce hybrid calls combining features from both parent species. So that indicates that this is some sort of instinctive song. Most songs are produced either without any recognizable external stimulus or in response to songs of neighboring groups. Only occasionally are they produced in response to alarming situations. The most frequent suggested reason is the strengthening of pair bonds, but that is debated. One potential function of the duets is the strengthening of pair bonds, but this is debated. If duetting has to be learned at the beginning of each pair formation, this would reduce the probability of partner desertion, since learning investment would have to be provided anew for each partner. So they tested this. They did a partner exchange on two pairs of Siamings. They showed a stable song pattern with pair-specific traits. After the exchange, new pair-specific traits occurred, some of them apparently achieved through directed effort of one of or both individuals. So this means that when they form a new pair, right, the species-specific themes are there, they're instinctive, but the complexities of the duet, where they form pair-specific traits, have to be learned for each pair, right? So if they've gone through all the trouble of learning these pair-specific traits, then it's much less likely that one of the mates will leave, because then they would have to spend all this energy learning new songs with a new partner. Pair-specific traits form as new pairs are formed, which costs energy and thus might reduce partner desertion. But they did not test pair bond strength and duet quality, so there's not enough evidence to fully say that this is pair bond strengthening. They tried a larger experiment that did test this, and they suggest that production of coordinated duets is indeed related to pair bonding. So this is interesting because one of the reasons for music that we saw in humans was the potential of increasing group cohesion, right? So maybe not pair bonding, but group bonding through song. So we may want to do something with that in just a little bit. Where I would like to go is looking at the phylogeny. So in singing primates, males and females both sing. In most singing primates, duet singing occurs. The four species groups of primates that exhibit singing and duet singing are not closely related, so I would like to see which groups these are. So we have is there a phylogenetic tree anywhere in the source? No. So we've got calling in the other great apes. Where is the list of singing primates? Somewhere in here there should be a list of singing primates. This is a book section, so it's possible that one of the other chapters in the book talks about other species. Singing is rare in mammals, and among primates is known only for members of the four genera Indri, Tarsius, Calicebus, and Halobatus. Just 26 species, and they're not including humans in that. But they say that they're not closely related. Hmm. Okay, so they're saying the other old world monkeys don't sing. So it looks like singing would have evolved separately in humans and in gibbons because the great apes that are closer to humans generally don't sing. They... Okay, so the key thing here is that pair bonding link, right? The function of music, I think, is going to be the most useful section. So if we go to music here, see the pair bonding function of singing in gibbons. Pair specific traits in song increase the strength of a pair bond. It is possible that similar group bonding could occur in human music. That last part is me, so we're going to put our citation there. This is going to be the Geisman paper for gibbons. All right, so the earliest evidence for music is in that range. Again, somewhere between 1.75 million years ago and 60,000 years ago, or 50,000 years ago. Singing probably evolved pretty early on in human evolution, right? Homo ergaster. I say early on in genus Homo's evolution. Musical instruments were probably already well established prior to 60,000 years ago, but they were likely made out of materials that biodegrade, and as such, we're not likely to find archaeological evidence for them. Music has a bunch of different functions, including group cohesion and cooperation or identification. We see that cohesion in pair bonding in gibbons as well. Musical instruments, bone flutes are the oldest evidence we have. Other instruments we can start finding a little bit later on, but before like the Neolithic, we're not going to find a lot of different types of instruments because most of the biodegradable instruments would be gone. With that, we're going to go ahead and call this investigation complete. We now have a nice connected little graph in our graph view. We have a few things that we can still look at, right? We have whistling potentially in the future, dancing, language, things like that. And at some point, we should see that as we make more and more of these little graphs, eventually some of them will start linking up and connecting to each other. I'm going to leave this up for a few more minutes. And with that, have a wonderful evening, and I will see you next time.